It is Monday. I almost forgot what day it was. And so we're here doing Monday Q&A. We have some really good progress that we want to share. So when we last chatted, we were going over the 2 different shooting prototypes that we had. So there was a lot more testing in that last night, and then we had a huge amount of progress made today, and we overcame a hurdle in software. So we're going to be touching on all those things. Why don't we start with what we were doing last night in terms of testing the shooters and some of the success and the choices we made from that.
Deal. So with the shooter prototypes that we were doing last night, we had a lot of good success with the 6-inch wheel shooter early. So we moved down to the 4-inch wheel shooter. A lot of good success with that throughout the night of testing. We really found a sweet spot really close to the tower with an almost vertical shot. A lot of backspin, very little curved guide on the backside. And so as we would shoot up the ball, it'd have a lot of backspin. It would hit the top of the goal and bounce right in. It was a really cool thing. We got it really, really consistently. And we were also playing with 2 different balls that we have here. One that's gone through quite a bit of shooter testing with us. So like we said last night, the outside casing has kind of broken down. It's a little bit softer now. And then we were testing with the brand new ball. So about as stiff and hard as they get. And so across the 2 of them, we were still able to make the shot without changing any of the setup within the shooter. Whereas when you're taking long-range shots, we needed to make some fairly significant changes to shooter setup, wheel RPM and that kind of stuff, depending on the compression of the ball. And so that's going to be a key thing for anybody trying to take long-range shots who wants, really, really high accuracy, is somehow sensing the compressiveness of the ball, adjusting your shot accordingly, before you take it. The other way to do it is a little bit reactionary. You take a shot, miss, and then dial the shooter up. Go fetch your miss, dial the shooter up, and then shoot again. That's going to slow you way down, take a lot of time, but it's a very human driver-oriented solution as opposed to a software-oriented solution. So we ended up, at the end of the night, we were really, really happy with where our 4-inch wheel test was. We actually added a simulated intake bar, so that was mechanically feeding the ball up into the shooter, and then it would take the shot from there. And that eliminated all of the human variable in how quickly or slowly we loaded the ball into the shooter. And so once we did that, we saw it was incredibly consistent, and we were really, really happy. And from that, we kind of solidified everything into our CAD model. And then I think that kind of closed out our night last night. We got everything ready to go, and we were feeling really comfortable. So that kind of brought us into this morning.
Awesome. That's very exciting. So one of the questions that we had that came in about the shooter was from Kyrell Jerome, which was, what kind of shooter are you using, and is it consistent so far? So you covered a little bit of that, but if you could explain specifically, what it looked like with that question, that'd be great.
Sure. So we have a 4-inch wheeled shooter, single axle with a curved guide on the opposite side from that single axle. So wheel here, curved guide going around. And one thing that we found is there's a couple key parameters. One, you want, instead of a wheel, you actually want more of a drum. This way, if you have any side-to-side motion on the ball, you still get a consistent shot, and you really don't want any of the ball to hang over the wheel on either side. And this will really help prevent you from damaging the ball, because it's kind of where that corner comes across is where you're starting to see some damage, some scuff marks and some things like that. So if the roller, if the drum is wider than the squishiness of the ball, then you'll kind of save yourself some damage. We also found that putting traction material along the curved guideway was really, really important. That eliminated any slip of the ball, and so it improved the shot. We really like that. We're actually using the Andy Mark green tread with some double-sided VHB, which I believe is most teams can get in their kit of parts. It's kind of a standard 3M product. And so that improved the shot, that improved our consistency, that improved our performance. We were shooting farther with that, and so we were really happy with that. And one of the things we found is we had this big long curved guide to the shooter, and we kind of kept taking sections of it away. And we found that we could still make the shot from where we wanted with a very, very short guide section. So that's something that none of us really expected, but we were really excited to see. So one of the things that we found is the closer you shoot, the more variance in your shooter doesn't matter. If you have a 3-degree variance, then the closer you are, the smaller that gap is out at the end. Whereas if you're way far back, that gives those two different flight paths time to separate out. So we kind of mitigated any inconsistencies by just taking really close shots. So that's kind of how we dealt with that. But we were still getting pretty good consistency from with the same ball. We could have a really consistent shot. Is when we switched from a different ball that we started to see some variance.
Excellent. So as you guys moved either later into the night or you came into today, where are we at in terms of the robot design choices, what the robot's going to be looking like? Where are you now?
And if somebody else wants to talk.
Nope, go ahead.
Yeah,
that makes sense.
So after all the prototyping we've done and after kind of finalizing what we wanted to do, with what we were showing the prototypes, we finalized everything we could in the design process, in the design phase on CAD through SolidWorks, and started this morning fabbing everything out. So we picked all the parts we needed, we got all the parts fab that we needed, we cut all our axles to length, we found all of the different things, and we are in the middle of assembly. So you can see Charlie right here assembling a little bit.
We are in assembly.
In assembly. And that's kind of the major phase. They can't see. So we could get something up and running, if not tonight, tomorrow morning, just for initial testing.
Awesome. Okay, so let's go. We have a question that came in from Ed Sparks, which was, any reason for not going with the Rhino tracks? Can we talk a little bit about that design choice?
Yes. So one of the major reasons we went with the pneumatic wheel drive is it's a pretty simple option for a lot of teams. So it's an off-the-shelf item you can buy to expand the kit-bot chassis to accept those wheels. So it presents another option for a drivetrain that can navigate, in our opinion, all the driving obstacles. So that's really one of the big reasons that we made that decision.
One of the other reasons was we knew that the team from Florida was doing that, so we knew that they were going to be able to show you guys all of the different variances, and driving over the different terrain obstacles. So we knew that that solution was out there and that somebody was doing it. And we had a somewhat specific chassis concept that we were going for, and so the chassis concept with the 8-inch wheels is something that we wanted to make sure that was shown and was out there. So that you guys could kind of see a lot of different things here in the first 3 days of the build season before you guys have to commit to too much stuff. So trying to get a lot of things publicly and get them out there was another thing that factored into our process.
Awesome. So the next question came in from Laura Zimmy. And it was, let's talk positive and negatives for Rhino Drive versus pneumatics. What were some of the things that you saw by using it on the field that made you decide to go one way or the other in the season?
So let me start by saying that driving performance is not the reason we made the decision. What we observed in testing was that the Rhino Drive actually crosses the driving obstacles more easily with less effort, but not quite as stable in respect to the angle that the drivetrain reaches as it crosses obstacles. So what you tend to see with the Rhino Drive as it crosses a driving obstacle is that it pitches up sharply and then kind of falls back over. And the wheel drivetrains seem to be more stable. You get kind of 2 bumps out of it, and that's really pretty much it. So definitely something to consider when you're looking at drivetrains is there's going to be a good chance that you could flip a robot over if your CG starts to get a little bit high and you have a drivetrain that puts you at a high angle of attack, if you will, for the obstacle. So that was one thing, because we wanted to leave ourselves a little bit of flexibility there if we needed to do things that were higher on the robot. I guess the other thing is simplicity. It's just a little bit faster to implement. I mean, we had the Rhino Drive in hand, but we would have had to do a little bit of work to make that do exactly what we wanted it to do. So I think those are 2 of the big things. If anybody has anything else to add.
Sure. I mean, really, the biggest driver was we really wanted to provide another option besides the Rhino Drive out there for teams. That really I mean, for all the other reasons that we're giving, that's the one that came up in our discussions the most. So we really wanted to get that out there, get teams a good pneumatic drive wheel solution, let them see that as well. Because we know, not everything's always in stock for everybody. So it's nice to have a second option out there. Yeah, I know.
Nope.
So, like kind of alluded to, the having stuff in stock, is an issue. But also the Rhino Drive, there's a financial component there that is not quite as much of a burden with the pneumatic wheels. So, there are a lot of different solutions out there. I mean, we're just talking about Rhino Drive versus pneumatic wheels. There are far more solutions out there to doing these things. These are just two things that are kind of the hot button topics right now. But they're not the only solution. So don't feel like you guys are painted into a corner like these are the only solutions. There's a lot of stuff out there, a lot of different things that you guys can do. So we're just happy that we're seeing a lot of stuff prototyped here in the first couple days.
And also consider, I mean, you guys can look at it that way if you want. We've prototyped 2 options that are reasonable choices for crossing the driving obstacles. And if you want to try something in prototyping that's a little bit more aggressive or a little bit different, then you can do that and know that, hey, if our prototype doesn't work out, one of these things will work too.
Awesome. So, first of all, hi, Frank. So just as an
Hi,
FYI.
Frank.
Hi, Frank.
And then,
The Frank?
yeah.
Yes, that is the Frank.
Hi, the Frank.
All right, and so our next question came in from Joel Hearn, which is, have skid forces been an issue at all?
No.
Neither of our drivetrains have exhibited any issues with being able to turn. No scrub from the wheel issues at all.
Yeah.
One of the things that we designed into the Rhino 2 is it does have a slight drop center on the actual plates. So kind of like a normal West Coast drive style, it does have a slight drop center to kind of alleviate some of the scrubbing issues that a lot of teams have had previously with track drive. But it also does have that shark fin and those pulleys. So,
And if you are choosing to buy the components, buy the belt and the pulleys and do it yourself, definitely consider that as an option. Just think about it kind of like you would a 6-wheel drop center in any other season.
Excellent. So we had a specific question come in from Justin McMahon, which was, are we allowed to grab the ball out of the neutral zone in auto, one of the 6 that are there?
Well, go ahead. You're the rules guy.
All right. So, thank you, Justin, for the question. During auto, G13 says during auto, robots may not enter the volume above the midline, which is the 2-inch white tape that cuts the field in half, and that's where the 6 boulders are placed in autonomous. So, the way that's interpreted.
Is it still you can only carry one during auto?
Yes, you can only carry one during auto, so you start with one already. So if you're pretty good and can get across in auto, score the one that you have. When coming back to grab that next one, you have to be sure that you don't enter the volume. So basically, don't break the vertical plane of the tape. If you do, it's a foul. If contact is made with an opponent robot beyond the midline, an additional foul is assessed, and then the opponent robot is immediately awarded a crossing of a closest defense. So that is the answer to your question. Thank you.
Awesome. So we just had a question come in from Cart Rig about, are you programming with LabVIEW or others? So Logan, that's your question again.
Right back to me. So we originally wanted to program. We originally wanted to program in Java. We had a couple of issues getting our RoboRio to talk to our computer, our programming computer. The frustration of dealing with it, we just went to C++. LabVIEW is able to be programmed, but we prefer structured text. So I prefer structured text. So as Danny calls me, the chief programmer. Whatever.
All right, so Andrew V. I had a question about, can a Spybot start with a ball in auto? Sorry, Logan, you're getting all the questions.
No. Thank you. Finally, rules questions. From what I had originally read, I don't remember seeing anything that said you can't. It was just each robot may start with a ball. May not be in contact with a boulder staged on the midline. Confined to their starting configuration, and yep.
So it's make sure you read the manual.
Yep.
But that's our feedback
Oh,
so far.
that one's a complicated. It's G7. There's 5 parts. The 5th part has 2 parts, so it's really 6 parts. So when placed on the field for a match, each robot must be in compliance with all robot rules. Not in contact with the boulder staged on the midline. 3 on only item left on the field by the drive team. Confined by its starting configuration, fully contained on the opposite side of the field from their tower. Breaking the plane of the auto line or inside their courtyard in contact with the castle wall and guardrail, which would be the Spybot. So,
yeah.
Spybot meets Part E, so you can still be loaded with your boulder.
Excellent. That sounds good. So the next question is from Frank, and he was wondering which defenses are we planning to be able to traverse?
So with our chassis, we are planning to traverse all of the Type B and the Type D obstacles. Those are the ones that kind of just the driving obstacles, being able to get over those. The high ground clearance of the 8-wheel drive, or the 8-inch wheels, gives us the ability to drive over those pretty easily. And then the Type A defenses, we have an active mechanism on the robot to be able to get after those. And the Type C mechanisms, we have a different active mechanism on the robot to handle those as we approach them from the neutral zone. But then we're also thinking that if we approach them from the courtyard, we can handle that with driving. So the plan of our robot really kind of focuses around being able to bust through all of the defenses, with the one exception of we kind of wrote off the low bar as it being a little bit too tight of a design constraint. So we're focusing on the defenses. And the shooter was kind of number 2 on our priority list, but we had very good success with that already, so we're very happy. So we're hoping to put together the full package of a robot, and see as much as we can do. So that's kind of where we're at.
Awesome. Okay, so Larry actually had a question. Larry Boland had a question that was, he overheard that there was a software hurdle that we overcame. So what was accomplished? Or what was the challenge? Or both?
So the challenge is with syntax. We had written the program in C++, as we mentioned earlier. The specific line of code that we were having problems with was inverting a motor for your drivetrain. The robot driver class is what you call to generally drive your robot. It makes it a lot simpler. So to invert those we wanted to invert the motors to basically turn the robot around without, having to go and switch each individual motor. So using .set inverted motor, apparently there was a problem with the way I had used it, but it wasn't enough for Eclipse to call it an error. So we had to go pretty much line by line through the code, putting it back in until we found what was causing the robot code not to compile on the RoboRio. So that was our biggest issue today, which, that can eat up a lot of your time if trying to find a syntax error that
7 hours straight.
7 hours from this from last night, an hour, and then 6 hours today.
2 RoboRios.
We tried.
A few friends.
Yep. Called friends, emailed some technical support at first, which was helpful. So yeah. Check your code, kids.
Nope. Software questions are popular tonight. So, Cartrig had a question. In C++, will you be doing automated vision processing, either or in autonomous or in teleop for shooting, etc.?
We do not plan on doing any vision processing. Doing a robot in 3 days. Yeah. We will have a metric ton of encoders on this robot. We've got encoders pretty much on every motor. So we will be doing some pretty heavy automation, but it won't be with vision processing.
Excellent. All right. Now we're, yes.
A word on the vision processing and alignment for shooting. Make sure that you guys don't forget that there are other ways to do that too. You'll see, we'll demonstrate it in our reveal video. We have a little bit of a trick up our sleeves, and there may be a few other ones that you can play off too to get the robot aligned without having to fight through vision processing software if it's a thing.
Awesome. All right. So then the question came in from Professor Potato Chips, which is he wasn't sure if we had already talked about this, but are we planning on scaling the tower? And if so, what mechanism design did you develop? Are we at the point where we can decide that we want to scale the tower? What's your thought?
Yes, we've asked this question.
Yes.
It's okay. We can talk about it again. Next time. So we would love to scale the tower. Say that first. We'd love to do it. We already have a lot of stuff on the robot. And so that one was it was bust the defenses, number 1, shoot the boulders, number 2, scale the tower, number 3. So we've kind of been chipping away. We had the manpower and the resources and everything to kind of handle the first 2 somewhat in parallel. But a lot of the design and configuration of the robot is really centered around number 1. And we're getting late in tonight. We have a little bit of time tomorrow morning. But at this point, we're not really thinking that the scaling of the tower is going to happen during our 3-day build. I know Florida and some of the other teams are doing that. So if you want to look at mechanisms or look at some ideas for how to do that, go check out their live stream or some of their videos. But it's not in the cards for us.
That was largely driven by the ranking points.
Yeah.
Just wanted to add that.
Cool. So, we do have, competition-style robot with bumpers over there. I was wondering if we could bring it over here and kind of show them what we have so far, if that would be all right. Yeah. I thought it might be easier.
Should we just take the crowd on a tour?
Yeah, we can do that.
And Brett's freaking out. I'll be right over here.
So, you can put the camera there, and you can have someone point to it, but someone needs to hold the mic and talk about it. There we go.
Man, narrate from afar.
Yep. So Brett is currently being amazing because we impromptu out of script pulled this on Brett. So thank you, Brett.
He had no idea we were moving.
Nope. Surprise.
Wait. Okay, so you narrate. I'm gonna ventilate, and we'll go from there.
Okay, so I think the first thing that viewers should notice is the fact that this robot has bumpers, which I believe is a robot in 3 days first. Yes.
What?
The drivetrain and chassis is complete and pretty rigid. Oh yes, big shout out to Mark Kors on the bumpers. They were done in like less than a half hour. It was awesome. So. Yep, we're using the bumper brackets from the kit of parts. You can see those there. Danny's pointing to them. Two at each end of the bumper, and then one on the side span.
The bumper is also in contact with
Yes.
outside panel of the kit chassis.
The bumper is actually low enough that the entire backing of the long sides of the bumper are in contact with the outside of the kit chassis. So those are fully supported along the full length. The bracket is basically just holding it in place. Yep, we're using the gearboxes are straight out of the kit. We didn't change gear ratios using the 4 sims. Just the pneumatic wheel expansion kit there. and that is complete now. The chassis is pretty well put together. We may have to do a little work to add some stiffness, but we'll look at that as we get a chance to encounter some obstacles. You can see the two big polycarb fins there that we've added that are going to provide the primary structure. We cut those on the NC router here at Handymark. So you'll see those have the mount holes for all of our features to do ball handling for the shooter. The thing that's absent from the robot, kind of in the back portion away from the camera, is that other manipulator that we're going to use to manipulate the drawbridge and the sally port and those obstacles. Although we may be able to do that with a manipulator at each end of the robot to some degree. There it is. You can see that's it's a two-jointed motor-driven arm, and it's got a bit of a number of different interfaces for those things on the end of it. We're calling it the Swiss Army knife at the moment because it serves so many different purposes. And I think that's pretty much where we're at now for the robot, unless I'm missing something. Huh? All right.
So one of the cool things that we did with this robot to really kind of take the kit chassis to the next level, and really try to add some stiffness to it and some robustness, make sure that, as we jump over all of these defensive outworks that we can, we know we're going to have a safe, reliable robot throughout, is we added a bunch of support panels all over the robot to add a bunch of stiffness. So you can see Charlie here, he's pointing out to some of our front panels. These tie across a lot of different structural components of the sheet metal of the chassis. We used a lot of rivets to make sure everything was very, very strong. Ben's going to come help Charlie, and we're going to show we have two panels on the top side of the robot, on the forward end of the machine. We also have one big, massive, solid belly pan to give a lot of stiffness on the bottom side of the robot. And so this is really one of the biggest elements in trying to make the chassis stiff and rigid. And that's going to take up a lot of the abuse that is going to get thrown at it through jumping over those defenses.
Awesome. All right, so now we will bring the camera back over. Thank you, Brett, so much.
Thanks, Brett.
All right, and we are back to Logan with another question. So Cartrig came with another question, which was, could you comment on encoder use and how you'll be using them? They're thinking that they're looking at RPMs and adjusting speeds. And then Larry Bolin also wanted to know what encoders are you using?
That's a good two-for question.
Yeah.
Wow.
Played off each other.
Apparently I'm popular tonight. So we've got a wide variety. On our drivetrain, we're using the E4T encoders. I'm not sure what's the gearbox.
It's the Tough Box Mini.
We're using the Tough Box Minis.
7-to-1 reduction.
Right. So the Tough Box Mini, there's an encoder mount integrated into that gearbox. So the E4T is meant for that. So we're using those encoders there. We're only using one channel. We're not too worried about distance. We just want more of a distance calculation there. Okay. We have a shooter encoder that is the sim coder, which was recently released by Handymark. So that'll be used for our RPM our calculations for the shooter. Sorry, I keep looking back at our board, which actually has our list of encoders. We have a dog bone encoder, which is our intake is what we're calling it, based on the shape of the polycarb that we're using. Yeah, there, that thing. So we're going to have an encoder so we know the position of that for our intake and for possibly the porculus lift. Okay. And then we have our Swiss Army knife that has an encoder on the base and then the encoder for the elbow. And those three, we're all using quad encoders. The integrated encoders on the PG 188.
PG 188. It's the integrated
So most of these encoders are integrated into, the motor or the gearbox. Most are for accurate position for our manipulators, and then speed calculations for our drive and our shooter.
Awesome. All right, so the next question that came in was from Mr. Shadow 2933, and that was about how many balls do you think you can score high in one match? And that's the boulders.
They do recycle, so it's hard to get all the boulders. We're thinking that we're trying to game plan around doing 3 to 4 cycles out of a mostly purely shooting-oriented robot. And I think a cycle isn't complete until the ball goes in. And so I think the optimal cycle is you drive into the courtyard, you take your shot. Optimally, it goes in the high goal. Woohoo! If it doesn't, then the fastest recovery, if you're trying to look at points per second, the fastest recovery is going to be grabbing that ball and throwing it in the low goal, which is a much higher percentage, and you can get that in one try. So take your miss, put it in the low goal, and then head back and grab another ball. And so three cycles is probably where we're going to see a lot of stuff happen. 5 probably being a really good, very very fast, very agile robot. So that's kind of where we're thinking. I think that there are going to be a lot of shooters who are going to have the control schemes to make every shot. So I think the 8 boulders that you need into the goals to get the capture.
No, weaken tower.
To weaken the tower. Thank you. The 8 boulders that you need to weaken the tower. I think that's pretty straightforward for an alliance. It's going to take a fair bit of work, but I definitely think you can get it done.
Awesome. So one of the things that we got asked about yesterday was about our team standard. And so we just wanted to bring it out from behind the screen and show it off because Betsy Baxter and Charlie both did a fantastic job at putting these together. And so we have this one. We actually do have another one, and maybe we can grab it before we sign off. But this is our Team Indiana Robot in 3 days standard, which is 2-spec and fantastic. All right, so the next question that I have for the group is, how do you feel about where you are right now? Oh, wait, hang on. Oh, never mind. It's only one way. I thought it went both ways. It's just corn on the back. Okay. Sorry.
Just corn. Just corn.
Yep, but how do you feel about where we are right now?
Should we do short answers on the table? Yeah, we'll do short answers on the table. I'm very excited with our progress right now. I think I'm very, very comfortable with our progress right now. And I'm very happy that everything, the Magic 8 Ball says that all signs point to sleep tonight. So that didn't happen last year, and that's a very good thing. It means we're getting better at this.
I think we're in a great spot. One of the big things that a few of us have pointed out is last year was pretty rough. We had to work pretty hard, and morale was in various conditions throughout the course of the 3 days. But I think the big thing this year is that there's a lot of first experience at this table, and I think everybody here, I speak for everyone here in saying that we all really like this game so far. It's going to come down to what the game dynamic looks like, but we're really excited about it. It looks like it's going to be a very interesting game to play, so we're excited about getting a robot done for it. So I think that's a big contributing factor in the fact that, we all feel good about it, and we're all excited about getting a robot done.
So yeah, as I kind of just said, I personally love this game. There's such a wide variety that you're going to see a different game every time between the robots, between the defenses. It's going to make every match unique. It may be fun, it may be a little slow getting started with, figuring out how audiences work, how the defenses get put into place from a logistics standpoint. But I think once we get over those hurdles like we usually do in competition season, it's going to get ridiculous. Usually, I'll be honest, most of the time I'm pessimistic towards kickoff, and I always, come to learn and love the game as we get farther in. So I'm just thrilled to see how this is going to go. Hopefully it's not down, but as far as personally for Robot in 3 days, mechanically and design-wise, I think we are just light years ahead of last year. Programming-wise, we're a little behind. So.
For me, I feel very comfortable where we are. I'm really excited for, again, I think the big factor of it that we love this game, and just what we were able to do and how we were able to solve the problems that we had given to us by this game, and realizing that we were able to make a really sleek design, make it do a lot more than we wanted it to initially, and getting to the point where we're more than comfortable. We're really excited and happy about it. It makes me really want to get this done as soon as possible, and I'm sure we can. So we'll get some sleep and we'll still get it done, which is a great, huge double positive.
Awesome. Yep.
You want?
I think that everyone seems much happier than what we had to do last year, and Danny got a lot more sleep, which is exciting. And I don't know, I worked all day, so everyone here is a rock star, and I appreciate you all. All right.
Yeah. I think it's going to be a longer night than these guys think, but yeah. But I do think we're going to get it done, though. More importantly, though, I also think that this robot. What the hell are you guys doing?
I said throw the tomatoes towards you, and Charlie picked up the banana.
Okay. Yeah.
It's close enough.
All right.
That's just mine.
Yeah, but more importantly on that, I think that this style of robot, maybe even this robot, could be picked on in Elimination Alliance at Champs, which is one of the things that I think is good in Robot in 3 Days Robot. There's a lot of little details I hope we can, we'll show you in our reveal video and everything that you might want to pay attention to.
Yeah, I haven't really been able to work on the robot a whole lot, mostly because I've been running the CNC mill and doing stuff out in the other warehouse to get your.
Working to get you parts.
Yes, I've been working to get you guys parts.
Actually, they are going wild.
And I'm working on the back orders. All right. Jeez, right? But okay. It definitely looks like they've gotten a lot done. I actually got CAD files and got to run the router for them today, and it was pretty early on, so it's going good. Betsy's turn.
I don't know what the question was.
How do you feel?
How do you feel about Robot in 3 Days?
I feel like the robot's not pretty enough yet. That's like my one job. It'll get there, and it'll be beautiful soon.
Cool. Next question.
All right, so Mr. Shadow 2933 asked about our autonomous routine, and he was wondering what it was.
Well, autonomous routine number 1 is full throttle over the defenses.
Right over the low.
So right now we don't have anything obviously programmed. We kind of need the robot for that. Hey, it is equivalent to what right now?
Like the middle of week 5.5. Yeah.
I'm sorry. If this is your team, wouldn't you want the programmers to have the robot by now?
Week 5.5?
Absolutely.
Week 5.5? Not one day. You wouldn't want driver practice right now.
No, I'd want about 2 days of driver stuff.
Okay. Anyway, so we haven't officially
Allowed to have driver practice?
plotted out an auto plan, but yeah, obviously first step, traversing the defense. Depending on where the easiest drivable defenses, that's where we would line up, straight over it. Hopefully we would line up with our center of the tower to get to our shooting position quickly and easily. But if not, we would probably try and figure out, a different auto routine for each position to get to our shooting spot, fire our ball, get 10 points, do a victory dance if we have time.
Awesome. Okay, so we're actually doing rapid fire questions at this point because we've had a lot come in and we want to make sure we can get to them. Yeah. So, our questions are they're not. No.
No more programs.
So, Slutter 1, 2, 3, 4, 5, 6, 7. How do you think a breacher bot will do in the rankings?
Very well. If not, it'll be picked very, very well.
Excellent. Sounds good.
Lightning round.
Mr. Shadow 2933. Do you think a bot that can score low goals and do all the outer works by itself will win a regional?
Early, yes.
Yes. I think that'll be that robot. Early regionals would be a very, very high seed. They'll get the pick of the field of a shooter robot to complement them. They'll get a pretty good robot as their third bot. I think that alliance could go very, very deep. If not win a regional.
And if you can get that ranking point by yourself reliably, that's a huge deal.
Big money. Big money.
I'm of the opinion, personally, that I think you'll see a lot of top teams run low goals in quals. It's getting those boulders in as quickly as possible ensures you get more RPs, which means that you seed higher, which means you tend to seed first, which means you pick better robots, which means you win. So you'll see a lot of people do that.
All right. From Laura Zimney, do you have some advice for teams who are having a hard time coming to an agreement? For teams who are split down the middle on a big decision?
Got time. Don't rush a decision. Your team is going to be working at this for 6 weeks, and if half the team thinks that you're going down the wrong path, they're not going to be putting their heart and soul into it. You need everybody behind it. See if you can maybe delay the decision, do a little bit of prototyping, figure some stuff out, and come back to the decision with a little bit more knowledge, a little bit more data behind it, and see if any of those opinions start to turn.
Awesome. And then continuing on, we were just complimented. We seem to be making decisions together so seamlessly. Is everyone laughing? Okay. Do you ever have arguments that set you back, and how do you recover?
How did that encoder do?
We spent a significant amount of time this afternoon discussing animatedly the merits of where we should employ encoders, because someone was upset about not having enough sensors last year, so he got sensors everywhere this year.
Yes.
And there aren't enough inputs. I'm not going to give you the microphone.
Next question.
Next.
When it rains, it pours, folks. When it rains, it pours.
Okay, so the question from Frank Merrick: when is the actual deadline for completion?
Noon tomorrow.
Okay,
For us, noon tomorrow.
Someone want to say that into the mic?
Noon tomorrow is actually bag day for everyone. Surprise! No.
Oh, that's painful.
Otherwise, it's
So it's
Tuesday
January
at
12th.
midnight local time on February the whatever it is.
So
6
yep,
weeks
so
from now.
Eastern time.
6 weeks
So
from
noon
tomorrow.
Eastern time on January 12th, Tuesday. That is when our big time is.
Yes.
Okay. Oh, they're laughing about my Wisconsin accent. Okay. And then Cartrig asked the question of, they want to know about the deadline, but then they also were wondering about our final reveal video. And I also think that's a good time to chat about our, last Q&A, which we were going to be doing on Thursday. So.
Frank, since you're watching, can we put in the manual that this is the way you have to show red cards at competition with chainmail?
All in favor?
Aye.
Oh my goodness. Okay, so but anyway, answering the question. So our final reveal is Thursday before our Q&A session, if Brett agrees.
Maybe.
Come speak. Speak, Brett.
Yeah, Thursday
Just like last year.
from 7 to 8 or 8 to 9
How are we doing?
in person like last year. It was on the logistics agenda. Yep.
This is news to some of us.
Well, anyways, we will have a discussion, and you can check it out for our final Q&A, and we will make sure people are aware of when the reveal video. Brett says that the reveal video will be available on Thursday for teams to take a look at.
And so it shall be done.
He also said that head refs need to practice that face.
Yes, we do.
Excellent. Okay, so then I had a couple questions for Danny.
Okay.
So why didn't Danny draw dinosaurs on our order boxes? We asked nicely. Says no problems. No problem.
The warehouse gets kind of crazy, like Looney Tunes crazy. The days just before kickoff. This year with kickoff moving back, there's a lot of orders, a lot of fun stuff, a lot of people trying to get ready. So we'll put it on the next set of boxes and maybe throw in some stickers.
Okay, so then the next question from Snow Problem, which I kept until the end here because they were pretty amusing, was, Danny, have you guys considered having an exhibition match against us at IRI yet?
We would love to. It's getting all of the Robot in 3 Days machines together to play some matches has been something that we've tried to figure out, where to do it. For since there's been more than one, it's always been a thing to try to get that robot out on the field. We'd love to do it at IRI. I think around the table we've got some connections to the IRI planning committee. We can ask some of the right people, and they have a long lunch break too. We can always do it then. So I think we'll love to do that. If maybe if Frank can help us out and give us a slot at the World Championships, we'd love to play Ri3D robots at the World Championship.
That doesn't count for Indiana.
So we would love to get all these robots to play an exhibition match together. It'd be a lot of fun. Let's work this offline.
So in terms of that question, that's no problem posted. Cartwright had a question about can we have a scrimmage on a real field over the next couple of weeks so that they could see how the gameplay would work. And unfortunately, I'd have to say that isn't quite possible because we are spread out all over and we are all moving into a solid build season. Yeah. So
it's,
yep.
If hopefully we can get a lot, we'll be able to get these robots together after the season, but all of us, all mentor teams, Snow Problem, Team Ri3D 1.0, Team Redacted, Team Cockamamie, all of these people are all mentors. We all love going back to the teams that we work with. And so unfortunately, there's just no free weekend from now till championships. So we'll see what we can do.
Excellent. So Omnibot 1000 had a question. Are we going to be posting the CAD design for your final robot?
No. What we're going to do in terms of posting documents, we'll post a few things, a lot of pictures, pictures of the robot, pictures of the CAD. We'll also do like a 3D PDF. That way anybody can download that and spin the robot around and take a really close look at it, zoom in on various features. But we don't want to give anybody a turnkey solution, and just say, hey, copy paste and go. So we'll leave you guys to kind of figure out the minute details, and hopefully you take our robot, use it as a springboard, maybe combine it with other features from some of the other robots. A lot of the stuff that you guys have thought of and you guys have created. Your imagination is going to be completely different, than anything that we've thought of. So don't be afraid to try your own thing. Take what we've done, use it as a springboard, definitely, but don't just copy it. That's not cool.
Yeah.
Yep.
So small addition. As much as we love our robot and what we're building, I don't think we all want to see clones of it everywhere on the field. So, take take from the best, make the rest. So that's trying
Make
not
it a
to
meme.
get too big of an ego. We are not quite the best.
All right. So the next question, rapid fire. We're going into rapid fire. What is the average score for a single robot during week 5?
42. Answer the lifestyle question.
No, higher.
For a single robot?
For a single robot, though.
73. What? Wait, average? What's the
Yeah.
question? What's the
What's
question?
the average score for a single robot during week 5?
62.
53.
I say 42.
55.
25.
Logan copied me, but 42.
100.
And I'm going,
$1, Bob.
Nope. And I'm going to the fortune teller from the kickoff video. Thanks, Michelle. And we'll just ask her what she sees in her magic ball. Also, don't forget to scholarships first. Alumni, yay.
Renee, you know what you have to do with scholarships? You have to remember to
Apply.
Awesome. Logan, question for you from Erica. Are there any rules that appear to be easily overlooked by teams?
all of them.
Well, from like G5 down.
Section 3. And 4.
I don't have one that immediately comes to mind, and I haven't fully memorized numbers yet.
The secret passage isn't part of the courtyard.
Hey-oh.
And on that bombshell.
On that bombshell, are we ready for inspection yet? Asked Ed Sparks.
The inspection checklist isn't out yet, Ed.
Oh.
It's
All right.
really a sign you've done something right. If
That's-
the robot is done, the inspection template.
Sorry, guys, that's going to get us a fail.
Oh, so sad. All right. Okay. So let's wrap it up with this last question. What is left for this deadline tomorrow? What do we have remaining that we have to do?
Programming. Programming, assembly, and that's just about it. Testing. Well, yeah, that's part of programming.
Driver practice, flame decals.
Flame decals. Yep. Okay.
No, not really. Though.
Horsepower. Yeah. But
I know. I was just saying for you.
high rod flames for horsepower.
I think we need a fire-breathing dragon.
Yes. Agreed.
Yeah,
Final image?
dragon to attack the castle would be
Yes. All right. So thanks everybody for joining us for Q&A.